give you some hints and tips here on how to do the pre-lab for this iodination lab, this kinetics lab. Now, the first question is asking you for the moles of acetone here, and I do give you a hint. And what I say is that the moles of acetone, moles of anything really, is going to be equal to the molarity, which is moles per litre, so the molarity of acetone, times the volume of acetone, but that has to be in litres. So you are told the molarity here, and it's 4.0 molar, but then you would multiply that by the volume of the acetone in litres, which is going to be 0.0100 litres, and that will give you the answer there. And question 2, you're looking for the molarity of acetone in the reaction mixture. That's once everything is added together. And you've got to remember that this is going to be a solution, but total solution here. Total solution volume includes everything. It includes 10 mils of acetone, and then 10.0 mils of HCl, and then 10.0 mils of I2, and also 20 mils of, should be plus there, 20.0 mils of water. So that'll give you a total volume there. And what you would do for number 2 is calculate the moles of, it says acetone again, which is what you would get from the previous problem, and then you would use the total solution volume here, which is going to be all of those things added together, and that's going to be converted again into litres, just like we did previously. Now question 3, we're looking at the rate for the iodine, and for that what you're interested in is the moles of iodine converted into the concentration, just like we did earlier. So I would do the same thing again. I take the molarity of I2, I'd figure out the moles of I2, and then I would look at the molarity of I2 in the total solution, and that's very similar to what we just did in problem 2. The equation that we're talking about to get the rate is equal to the change in concentration of I2, which means it's disappearing because it goes to 0, and then that's over the time, and you're given the time there as well. So you should be able to figure that out based on the information I've just given you here. Now for question 4, you should have done this in class, but if you haven't for some reason, this is how you would manage it. What you need to do here in order to get the rate the order with respect to each of these A, B, and C, you're going to need to find the ratios of different rates with these rate equations. And if you're interested in, for example, finding the rate with respect to, say, B, what you need to do is find 2 reactions where everything else except B is going to be the same, and this is so it cancels out. So let's say this is B here, and what I see here is we've got 1.0 and we've got 2.0, but you can see everything else is the same. We've got 1.0, we got 0.010 over here, and this is for A and C. Of course the rates won't be the same, or they may or may not be, but in this case they're not. So what you would do is you do this kind of thing. You'd say rate 1 over rate 2 equals K, and this would be A to the M, B to the N, and C to the P, and those all have a subscript of 1, and we do the same thing on the bottom one here. Now you can see that the concentrations of A are going to be the same, so they're going to cancel. The K's are going to cancel as well. The C's are going to cancel. All we're left with then is 1.0 times 10 to the negative 4 molar per second over 4.0 times 10 to the negative 4 molar per second equals, in this case, it's going to be 1.0 over 2.0 molar, and that's all to the power of m. So what we end up with here is 1/4 equals 1 over 2 to the power of m, and we can solve for that. M is going to be, if you've got anything like this, and I'm not going to solve this for you. You can solve it on your own. If you've got x equals y to the z and you want to solve for z, you can do that by saying z equals log of x over log of y, and that will allow you to solve for that power there, that z. So you can see how you might solve for the m value here, and you have to do that in the lab anyway as well. So that would give you the order with respect to B. You'd do something similar for A. You'd have to find reactions where A was different but everything else was the same. I'm talking about B and C. And for C, you'd have to find two of those that were different where A and B were the same. But I'll leave that to you, and then you can get the orders from those in that way.